Hi friends, going into Unit 4, Day 2. This one is about exponential functions. So this is kind of a big crux of what this particular chapter is about. The chapter is on exponential and logarithmic functions. So this one really focuses heavily on exponential functions. Exponential functions are defined by f of x equals b to the x power, where b can't be 1, and then b has to be greater than 0. So we can't have a negative value here, and we can't have 0. But also note that b can't be 1. 1 raised to any power is just 1, so it doesn't grow exponentially or decay exponentially. So here we have evaluating exponential functions. If f of x is equal to 4 to the x, evaluate the following. So when it says f of -2, that just means you put in -2 in for x. So you have 4 to the -2 power. 4 to the -2 power is the same as 1 over 4 squared, which is 1 over 16. And then if you have your calculator, you can do 1 over 16 as the decimal and get the decimal value if it's exact. And I'm killing time until I have it. And it is 0.0625. Oops, another 0 there. So 2/3, f of 2/3 is going to equal 4 to the 2/3 power. So 4 to the 2/3 power gives us this value when you plug it into your calculator. And so you might be like, well, what is exactly going on here? This is a decimal. Well, let's go back to what this really means. If this is my numerator and this is my denominator for this particular exponential function, what I really have is the cubed root of 4 squared, which is the cubed root of 16. The cubed root of 16, again, going into the largest perfect cubes that I can take out of here, that would be the cubed root of 2 cubed times the cubed root of 2, cubed root of 2. So this is going to be 2 times the cubed root of 2. And then 2.15, so again, if I put this in my calculator, I get this. Now what's really happening is, again, this I can convert to a fraction. I'm just going to show you off the side so you can see this is 215 over 1,000. So it's the 1,000th root of 4 to the 215th power. That can simplify, that reduces. But for this particular course, this particular class, I just want you to know that if I'm asking for this, I would be asking you to approximate at this point. So we're just going to talk about the approximation, the decimal approximation. I will tell you to round, what decimal point to round to. For now, for values, go ahead and round to 4 decimal places. We're going to keep that for a while. So if I don't tell you, and I just say round, 4 decimal places is good. So this one, we're going to say this is approximately equal to 19.6983. And then 4 to the 5th gives us an exact value. 4 to the 5th is equal to 1,024. So these are just some values, just kind of getting into evaluating exponential functions. The graphs of these, there's 2 cases. There's either a case where we have some value greater than 1, or we have our b value, our base, being between 0 and 1. These do different things graphically. We call this first one growth, and we call the second one decay. As you go from left to right, this exponentially grows, and this exponentially decays. We'll see an example of that in the next video.